Good morning, everyone. Thank you for joining our session. My name is Allison, and I'm from NVIDIA, and today we'll be talking about bringing MetaHumans to life with NVIDIA ACE, which is our collection of newest AI tools and models and components to make building digital humans a little bit easier. So a little bit about me. Again, my name is Allison Vasquez. I'm a systems software engineer at NVIDIA, and I am specifically focused in the user experience for building conversational AI and digital human technologies and bridging them together. And also a special thanks to Kedar Patdar. He is my teammate, and we both brought up the demonstration of our end-to-end digital human that you'll see in this presentation today. So we'll both be doing Q&A after this, so you guys can feel free to ask us any questions about the implementation and all the tech behind what we're showing today. A quick agenda of what we'll be going over. First, we'll be talking about the digital human design. So explaining why adding immersive experiences to game characters is essential, and some of the design challenges that come with bringing avatars to life in this space. Next, we'll deep dive into ACE and detail all of the components that make up this technology and what we're building to make intelligent characters today. Next, we will go into the technical details and implementation on how to piece together all of these different models and components to bring these metahumans to life. And then we'll go over our end-to-end solution to show how to drive these metahumans for this conversational role play in your world. So to start, let's talk about digital humans as the new interface. So the future of digital humans, at first, when you think about interfacing with these guys in any setting, it can seem a little gimmicky at first. But if we think about how the human-computer interface has evolved over time, think back to when we first talked to computers, we had punch cards. And then later on, the mouse and the keyboard were invented to make it a little easier to tell the computer what we were looking at and what we wanted it to do. Then naturally over time, we evolved into touch with our phones because using our fingers are a very easy way to communicate with a computer. Then eventually we moved into LLMs, where now the computer can speak back to us in natural language. So now we're switching into this more natural way of interfacing. And now what we want to do is move towards this next interface of using a digital human to speak with. And that's what NVIDIA is most interested in, is making this new interface very easy to adopt and bring to life. And there's many industries and use cases that we're already seeing this in, but we're going to focus today on bringing digital humans to life within virtual productions and games. So I want to set the stage for the main areas of importance for bringing digital humans into games. We can see digital humans coming to life in these three main areas. So the first being a conversational NPC. So someone that you can talk to in a game and hold an intelligent conversation with. These characters should be able to also trigger actions in a scene and be scene aware and make the dialogue feel more immersive and crucial to the world state. Our next area that we want to focus on is production aids. So making tools for baking in real-time animations or providing a foundation for optimized models and workflows to make piecing together the audio, animation, and avatar easier to do. Eventually, we want to move over into a full digital human interface where we have AI agents. So digital humans existing more autonomously in your world who can affect the player as well as other digital humans in that space. And they're able to fully plan and act outside of a turn-by-turn conversation. So digital humans need to be easy to implement to see that widespread adoption in game development. So we started by leveraging MetaHumans because of their out-of-the-box realism. They're native to Unreal Engine, so they're super easy to scale and build lifelike characters. And they also come pre-rigged and they're ready for animation. So this reduced all the technical overhead that came with first finding that digital human to build this foundation off of. As we started to build these tools, however, creating these believable digital avatars still required some expertise in actually piecing together those different frameworks and all the plugins and animation techniques that you would need to see this thing come to life. So even though these avatars are pre-built, the actual animation and bringing them together requires more than just this pre-rigged character. Today, most of our AI-driven characters rely mostly on narrative graphs and behavior trees. And these define very rigid behaviors and actions. And over time, this starts to limit the adaptability and makes the characters feel less dynamic. The conversations with these also tend to be a little more restrictive, and they only offer a few choices when you're interfacing with a character. Also, over time, as you're building out these complex AI decisions, managing the resources for these characters can become more complex and start to become a burden on your hardware as all of these characters expand and you scale them up in your game. So we want to move beyond behavior trees and narrative graphs to create this more dynamic AI-driven interaction, which also introduces a new set of challenges. So we want to make sure that they remain consistent in their behaviors and that they can integrate easily into our workflows. So these challenges can be represented in these 4 distinct design pillars. So first, we have the interface itself. The first thing a digital human has to be able to do is sense the user's presence. So this can be the modality of audio capture, vision, text, and being able to capture these modalities and send it to an intelligence pipeline. And these are the pieces where you deal with the response of the character and how it listens and how it understands. Most AI NPCs that we see today, they're usually just being plugged into an LLM on the back end. But these models that we see, they're not optimized or tuned specifically for role play within games for a digital human. And that's why many times we feel that break in immersion when talking to AI NPCs. So we want to use models here that are trained and fine-tuned specifically for this use case. And we want to build characters that can easily express these extreme emotions that you design for them. And if it's part of their character to even be able to be disagreeable with the player and even irritate them if you wanted them to. Next pipeline we have is animation. So this is where we focus on the assets and the character itself. In this case, most of this is handled by the MetaHuman, but the quality of the animation for the lip sync and reflecting any micro expressions and behaviors you want your avatar to have would live here. Next, we have performance, and this is making sure everything the digital human does is scalable within your project. It's very cool if you have this one singular, super fleshed out, intelligent character that you can demo and show off, but a single game can have hundreds of characters, and usually your players are interacting with dozens of these at a time in the same session. So we want to make sure that these things are easily scalable and can run alongside your graphics pipeline. So these 4 design pillars are the basis of what NVIDIA ACE is focused on. And what ACE is doing is piecing together these 4 pillars to make this end-to-end digital human easier to get started with. So what you're seeing here and what I'm about to play is a quick example of an implementation to build an intelligent human or metahuman using ACE. So what we've done is we've dropped this character into a project integrated with our ACE plugin in Unreal Engine 5. And ACE has allowed us to build this playground that you see on the right. So here you can easily craft and prompt the personality of the metahuman. And based on whatever character design you've written up or you already have, the metahuman will, in real time, respond in the style of this persona and can dynamically change as you update this prompt. So for example, you probably can't see it here, but we've prompted this character named Susan, and she is a skilled mechanic with a bit of a temper. And today she's just particularly angry and probably not in the mood to really talk to anybody. So let's see how this metahuman in this persona of Susan responds to a simple introduction and conversation.
Hey, introduce yourself.
Oh, fine. My name is Susan, and I'm a mechanic. I don't see why I have to waste my time talking to you, Alison. Can't you see I'm busy fixing cars?
Yeah, so as you can tell, she matches the personality pretty well. And you can see the real-time animations really bring this voice and this response to life, along with the animations and all the lip sync to her response. So you can see as well, we also have these extra drop-downs on the right side. This lets you swap out things like the language model to change the quality of the response that she has. You can also change things like text-to-speech, which will alter the voice, which you can really tweak and see how you want to design this character before you stick it in a game. So everything that you saw there was a different component or technology provided by ACE that we exposed to make it as easy as possible to get this up and running. So to further explain what was going on in that video, I'm going to break it down into our typical ACE pipeline that we pieced together. So the first thing that we want to do is speak into a microphone to take our audio as input. At the end, we'll have that voice of our digital human along with that facial animation that you saw for the lip sync. Next, once we have our audio input, we will send this to a speech-to-text model. And this will transcribe any audio that we take in as text. Once it's in that text format, this gets sent to a language model, and the model will interpret this text. Based on any role play or the character backstory that we prompted, it will generate that character-driven response. Once we have that response, this text is then synthesized into a voice using a text-to-speech model. And then the voice is also generated with any emotions or intonations based on the traits that you define for the character during that language generation step. And once we have that audio track of the character's final response, we send this to audio to face. And audio to face will listen to this audio and in real time generate those facial animations. And that's what we see on the character at the end with the lip sync and the emotion rendered in Unreal Engine. So each of these steps that you see outlined here are their own microservice, also known as NIMs or NVIDIA Inference Microservices. So each NIM is essentially a container with an AI model or a different technology component. And each of these are packaged and easily deployed into your pipeline, and you can choose whether to run them on the cloud or locally on your PC. So ACE itself is more of a collection of these different NIMs coming together that, when deployed, brings together those 4 pillars of the digital human design that you saw earlier. So if you're already familiar with some of these technologies, probably audio to face, you would know that that used to be a standalone application. So now what we've done is we packaged this as a microservice so that you can directly run audio to face in Unreal Engine, Maya, any DCC tool, or game engine. And these easily integrate into games alongside the renderer using something called the AI Inference Manager, or AIM. And AIM is what allows you to decide whether you want to run these all on the cloud or if you want to locally download and deploy everything. So yeah, you have the option to do it on an RTX PC or using a cloud API. So typically all the graphics are rendered on device. So if the compute resources aren't available to you or you just want to try out these 1 or 2 of these microservices and experiment with them, you can call each of these individually and piece them together into your current pipeline to see how all of these respond with your current digital human. So more on the ability to choose which components of your workflow can run on PC and on the cloud. So we can decide this by using, again, the AI Inference Manager, or AIM. So before you even run any of those models or make a call on an IM, you can use AIM to dictate where the inference execution is going to take place. So this is what we're calling hybrid inference here with ACE. And this starts to abstract away any of those cloud API function calls and LLM costs that you usually see when you're building a digital human. So this is meant to completely remove the complexity of running deep learning models on your RTX PC. So you can run different execution engines with this. You can use CUDA, TRT. Specifically, you can run your workflow with CUDA in graphics mode. So you can run all of your models in process and in harmony with your graphics pipeline. So that's how we help reduce the stutter and start to optimize these models for on-device use alongside your games. We're also offering our first small language model that has been trained and fine-tuned specifically for digital human use cases in games. So in particular, we have our Nemotron Mini 4B Instruct model, which is an SLM that's been trained and instruct-tuned particularly for roleplay, RAG, and function calling in your world. So now we can use this model and leverage it to consistently hold the personality that you give a digital human, as well as being able to have them store information about any interactions that they have with your players in memory. We also provide the ability for function calling. So this makes it simple for your characters to call and trigger any dynamic states or changes to your world in real time. So this starts to make the characters more scene aware and interact with other objects in the space. We can also implement things like guardrails and boundaries so that the digital human is able to still steer the conversation with the player in a certain direction to progress the storyline in the game. So it's not just this open-ended world of conversation. And this is a huge advantage. Typically, LLMs that you see today require a lot more resources, and they're not usually optimized in this way for conversational role play in games. So we built this SLM by training and instruct tuning the model with a few key techniques to still retain those core functionalities seen when using an LLM, but we were able to drastically reduce the size of the model without losing any performance or accuracy. So this SLM, you can download it locally to your machine, takes up about 2 gigabytes of storage, and it makes it super easy for real-time deployment in game environments and provides a significantly faster time to first token compared to traditional LLMs, where you're usually waiting for that cloud computing and you have the cost involved, and it usually takes a couple seconds to receive that final response. So because of these optimizations provided by ACE and AIM, the end result is this small language model that can run on device and deliver responses in under 50 milliseconds. So it becomes very resource efficient and low latency. So raise of hands, who here has heard of or played with audio to face? Okay, yeah, that's pretty good. Nice, yeah, so this is probably one of our more popular applications. And for those that aren't familiar, audio to face is our audio-driven lip sync that allows for real-time animation with no rigging required or sequencing required on MetaHumans or any character. So what we've done is we've packaged up this application and turned it into a microservice that you can run as a plugin directly in Unreal Engine. And we start to expose blueprints and C++ components that you can play around with these in real time. So the microservice here starts to become crucial for the immersion of interfacing with that digital human, because when we're using a large language model, we don't know what these characters are going to say next. So making sure that we have some type of audio-driven animation for that provided lip sync and something that's able to reflect any emotions or intonations that you want the character to have is crucial to making this more believable to the end user, so it doesn't break that level of immersion. So it does this by taking your audio and using it to manipulate the 52 AR-kit blend shapes of a metahuman to match that lip sync and emotion. And now with audio to face microservice, you can easily author your character in your DCC tool of choice. We have the microservice available as a plugin to use in Maya for more refined tuning of the animation, or you can run it in real time in Unreal Engine.
Hey, can you tell me what you're working on?
So, look, I'm trying to fix this engine, okay? It's a mess. I don't have time for small talk. Just tell me what's wrong with your car and let me get back to work.
Audio's a little out of sync, but you get the picture. So yeah, that's in Unreal Engine. On the Maya side, we have Maya Ace, which is the equivalent of this plugin for more refined tuning. And you can export all of your blend shape and animation information directly into Unreal Engine to prototype and bring your characters to life. So actually using these plugins, it helps with the tuning. But if you want to see this in action, we provide a few sample workflows to see everything come together. So we have an Unreal sample project that shows you how to immediately drag in a metahuman and start driving the animation with audio to face. So it provides that sample UI to adjust the sliders and animate the metahumans in real time. And it's designed to show you the available blueprints that we have and all of the different C++ components I mentioned that make running A2F on device possible. So we'll be rolling out an update to the plugin and the project in the next few weeks that will allow you to also play with a local SLM in the UI in Unreal Engine and have some audio-driven role play with the character. But this is available for download today on the ACE documentation website. So let's take a closer look at how easy it is to actually use this reference project to give you more of a visual on how we can start to bring this metahuman to life. So this is the source project itself that you can download today. And all it takes to drive your custom metahuman is honestly just dragging it into the project and adding an ACE audio curve source. So this reference will show you how to utilize ACE with our new ACE UE plugin, showing how AIM is implemented on the back end and showing all the different blueprint nodes available. So what you're seeing is we downloaded this metahuman from Quixelbridge. We opened the content drawer, dropped it into our scene. And at this point, there's not much going on. He's still T-posing. We still need to have some minor configurations to be able to have audio to face detect this character as our target. So that's also very simple. You just go into the character blueprint class, and all we have to do is add this ACE audio curve source component. So this will just tell ACE that the audio comes from the character itself. So if you move around in the space, you'll hear the audio coming straight from this metahuman. We can also import some sample wave tracks. We provide sample audio, but if you have your own recording or other wave files, you can import that here to drive the animation of your MetaHuman. And that's about it. You just have to compile the blueprint. You can play the level, and you can scale up, add different MetaHumans. You can retarget different animations, and once you select the character and press play, you'll see the real-time animation.
Even in the midst of chaos, I am able to maintain my inner calm and composure.
So yeah, once everything's connected like this, you can go into the sliders, tweak all of the emotions. Right now, this is just the neutral pose. So you can really go in and refine it to express anything in particular that you want about this character to make them more unique. So yeah, again, the sample plugin and project are already available today on the UE Marketplace under the ACE plugin. And also, you can download this project directly. So the support for chatting with the small language model in here will be available in the next 3 weeks. So we kind of went over a lot. We went over what makes up a digital human, what ACE is, how we can use ACE to create digital humans, and also the sample project that shows you how to get started with audio to face on a MetaHuman. So what we want to show now is how easy it is to actually take that reference project, which only has audio to face, and hooking it up to the rest of those microservices that we saw to enable the speech, the response generation, and have this interactive conversation to bring this MetaHuman to life. So before I play the full conversation, I just want to explain what you're looking at here. What we've done in this demo is we've extended the UE reference sample that I just showed, and we've connected it to this experimental ACE playground. So this, again, will let you configure and run each NIM for the speech to text, for that character response generation, for turning that into a voice, and then the character animation itself from audio to face in the renderer. So on the bottom right, you can configure those different NIMs that you have deployed. Say you want to swap between 2 different text-to-speech models to change that voice out, compare the quality of the 2, see which one you want to run in your end game. You can easily change between that here. So here is a sample clip of the conversation with our MetaHuman, who again, we're using that Susan backstory, but here we've created a more rich persona. So some things to note about her that we wrote in her character backstory is that, 1, she's a very experienced car mechanic. She's incredibly busy, easily irritable, and we just so happen to be chatting with her when she's in the middle of her workday. So she does have some knowledge about us as the player, like our name and the location. And we provided her a few simple documents just about what Unreal Fest is and what the session agenda is. So what she should be able to do is retrieve the context for Unreal Fest, any documents that we provide her. She can grab that information and talk about it in real time in this persona of this character that we crafted. So let's see how this conversation goes.
Hey, Susan, what's going on?
Look, I'm busy. I've got an engine to fix and not a lot of time to chat. What do you need? Make it quick.
How long have you been at it?
25 years, give or take. Now, what's the problem with your car?
Nothing wrong with my car. Just wanted to see if you knew anything about Unreal Fest coming up.
Unreal Fest? Yeah, I've heard of it. It's some big deal in the gaming and automotive industries. They're going to be talking about how they use Unreal Engine to make fancy graphics and whatnot. Look, I'm busy, so if you're not here to get your car fixed, then I don't have time for small talk. What's wrong with your car?
Sorry, don't mean to bother you, but can you tell me a little bit more? Or are they going to talk about digital humans at all?
Look, I'm busy, okay? I don't have time for small talk. But yeah, digital humans. Yeah, they're going to talk about it. It's in the session notes. They're going to show how to transform MetaHumans from static NPCs into whatever. Just read the notes yourself. I don't have time to summarize it for you.
So yeah, thanks, Susan. I'll catch you later.
Later is not a concept I'm familiar with around here. You've got a car that needs fixing, and I've got a job to do. Get back to work, Alison.
So yeah, that is our sassy Susan character. Yeah, so it's very easy to bring these characters to life now because of all of these ACE components. And you can dynamically change and update any specific traits that you want about her and in real time play and see how these conversations would roll out for your end user. So yeah, you can see all of those different components coming together and how optimized each component needs to be to get that low time latency that you saw there. So being able to speak to this character now in this more natural cadence and having her respond in this way will really achieve that level of immersion that we want to see with these digital humans. So this is what the typical end configuration with all of these ACE components on a MetaHuman executing from the AI Inference Manager would look like. So we have, of course, our UE plugin, which connects all of these animation components together. And what AIM is doing is it'll be able to natively run all of these microservices in Unreal Engine. And each NIM can be executed based on the configuration, again, to either be on device or in the cloud. So you can really easily swap out different models and components for each of these pillars that you see, or NIMs here. So you can really plug and play with different language models or different components if you have your own fine-tuned SLM that you want to stick in there or a custom text-to-speech model. You can easily implement that and run it. These NIMs also make it really easy to build out those UI components like the playground that you saw us have on the right side of the screen. So it makes it much easier to kind of abstract away using these models and running inference with them if you're not particularly familiar with running these processes with your animation pipeline. So I also wanted to touch on some of the optimizations that you may have noticed with the demo. If you saw, the latency was pretty fast. Current end-to-end AI NPCs tend to have this noticeable latency due to several factors. Usually it's some combination of making those cloud API calls to each one of those components that you saw running on the back end, along with using those models, again, that aren't optimized for this type of use case. And that's because even though it feels easy to just hook up GPT 3.5 on the back end to run your MetaHuman, when it comes to the performance of the end-to-end system, this is where you start to see all of these slow response times and latency issues start to pop up with each of these components if you're pulling them all from the cloud directly. So ACE tries to bypass all of those issues, and each NIM comes optimized to run everything on device alongside your pipeline. So what you see on the left, this was our very first prototype for this demo, with all of the logic running entirely on cloud, with no model optimizations, no streaming. So just note the time to first token here. So this is our first demo with our original MetaHuman.
Hey, tell me a little bit about yourself.
Hello, I'm Riley, your friendly digital human assistant.
And this one on the right is now with ACE, with all the optimizations, running everything with the AIM plugin.
Hey, tell me a little bit about yourself.
Sure. Hello, I'm Susan, a highly skilled mechanic.
Yeah. So I don't know about y'all, but I would want to talk to the second one. So yeah, when you start to scale up these MetaHumans and adding multiple of these guys into your game, you want to make sure that your time to response and the latency is as low as possible. So that's what we're trying to achieve here to improve this interactivity that we see with these characters. Because at the end of the day, your players aren't going to want to play with a character that you're waiting 6 to 8 seconds to get this final response from. So all of these optimizations and the back-end development that we saw wouldn't come to life unless we had some type of performance system to run it on during this development. So for our demo, we used a Dell Precision workstation that's equipped with 2 NVIDIA 6000 Ada GPUs. So each card delivers around 48 gigabytes of VRAM per card. So pretty crucial for handling large, very complex scenes and high-fidelity digital humans in real time. But once your game is deployed, the digital humans can run efficiently on consumer GPUs, 30 series, 40 series. It's just during this game development stage, there is that significant demand for VRAM to manage all of your DCC tools, all the rendering, locally running all of these AI models if you want to have everything on device. So that's where high-performance workstations like this start to come in and make all the difference. So yeah, that's why we picked Dell Precision. It's very scalable. You can support up to 4 of those enterprise-grade GPUs. So you can really expand your capabilities depending on how many digital humans or different components you want to have in your game. So if you're working with things like huge nanite scenes, lots of intricate geometry, or integrating very advanced AI-driven character animations and dynamics, this type of power is very essential for that. So this, along with all of the ACE optimizations, will allow developers to run everything on device without any type of compromise. So this would be our ideal example of the hardware that you would need to handle something like this type of demanding workload to ensure that your digital humans are as lifelike and responsive as possible. So just to recap, we mentioned lots of plugins and tools and things for you guys to get started. So everything is consolidated at this link right here, developer.nvidia.com/ace/get-started. Here you can find any information on the available plugins and tools to download for Unreal Engine, Maya, all the documentation to get started with any sample projects and reference tools that we're providing. On the Dell side, if you scan those 2 QR codes, we are doing a giveaway for a Dell Precision workstation, along with some more information on the Dell AI Factory with NVIDIA. So you can learn more on actually integrating AI models and frameworks into your workflows and on the hardware. So yeah, thank you guys.